Hi, today we are going to read about complex number. Complex number, first we will try to understand why is required a complex number. Already we have the real numbers. Before complex number, we have the real numbers which are either positive or negative or 0, and till now we have seen that we can solve a question whose solution is either positive or negative or 0. This we have solved it. But what about the equation such as x square plus 4 equal to 0? So we say the solution is not possible. Or no real solutions. So what if the no real solutions also not possible? Then what we can do about this equation? How we will solve this equation where x square will become minus 4? How we are going to solve it? To solve this we need complex number concept, which we will try to understand how it is there. First of all, we will go to the one I. This is called as iota. First introduced by Euler. Euler was a mathematician. It is an imaginary unit. How it can be used, I will tell you right now. It is an imaginary unit. Here iota I equal to I square actually equal to minus 1. So this is the concept behind this. To understand the complex number, I square is equal to minus 1. I is equal to square root of minus 1. From this now we can see the x square is equal to actually 4 into minus 1 equal to 4i square. From here you can say that x equal to 2i. So now we have the solution here. Now come back to the theory parts. What is the complex number? Complex number, a number of form x plus iy. You can see this x plus iy, where x and y are real numbers. By this we can say example 3 plus 4i 2i, as you can see here 2i. So 2i is the complex number. Point is this: now we come to the part x plus iy. Here x is also called as real part of first x plus iy is denoted as z. So here x is a real part of z and y is called imaginary part of z, also represent as real z, rez or rz or rez. This is also represented as iz or inz or imz. Now we will see purely real or purely imaginary. What is the meaning of purely real complex number? By the name you can see the purely real complex number means what? This is the real part of z, this is the imaginary part of z. Purely real means the z, the complex number whose imaginary part should be 0. So we can say that imaginary part should be 0. So example will be 4, 3, 2, 4. By this we can see that all real numbers are complex numbers. So we can say the all real numbers are complex number. So this is the key point over here. Now we will come to the purely imaginary complex number. Imaginary complex number. So purely imaginary means there should be only imaginary part, not a real part. That's mean real part of z should equal to 0. So example will be, we have seen this 2i. So 2i, 3i, 4i means there should not be a real part, only imaginary part. That's all. Okay. Now here we will summarize key points. All real numbers are complex numbers. Second, number 0 is what? Real or imaginary? So here we can see 0 is real number, purely real because imaginary part is 0, and purely imaginary because real part is 0. So this can be summarized like this. Yes. Now come to the equality. Okay, so we suppose we have been given two complex numbers. We have been given two complex numbers. 4x plus 3y, 3y. One is z1, second z2, 5 plus iota 6. I am going to say I always, sometime iota, but I, here I means iota. In the real world, people used to say iota. I am going to say like I only. Okay, so whenever I say I, you should understand iota. So z2 equal to 5 plus i6. What is the meaning of the equality? If someone says z1 is equal to z2, then what is the meaning of this? This meaning is this: real part of Z1 should equal to real part of Z2 and imaginary part of Z1 should equal to imaginary part of Z2 separately. So from here what we can see 4x equal to 5 and 3y equal to 6. Now key points, we cannot say this 5 plus I6 is greater than 6 plus I3. We cannot say anything about it. That is complex number. In case of complex number, inequality relation does not hold. Inequality relation does not hold. Having non-zero imaginary numbers parts. What does this mean? Means if there is imaginary part of any complex number, then inequality will not hold. So this doesn't sense anything. So we should not put any inequality sign. Equality is okay. Equality holds, but inequality does not hold. Now we are going to see the algebra of complex number. Algebra of a complex numbers. What is the algebra of what here we want to understand? Algebra of complex numbers, we want to understand basic addition, subtraction, multiplication, division is performed or not performed, can be performed or not performed. Okay, so we will see. So first we will going to see addition of a complex number. Means can we add it or can we not add it? If we can add it, how we can add it? Addition of complex number. Yes, we can add it. How we can add it? If z1 is equal to x1 plus iy1 and z2 equal to x2 plus iy2, how we can do it? We will add real part to real parts and imaginary part to imaginary parts, keeping I intact. You can see z1 plus z2. So we are going to add a real part to real parts. x1 plus x2. We will make it in a bracket to look, and I imaginary part to imaginary part. Simple. Example, z1 equal to 4 plus I3, z2 equal to minus 2 plus minus 2 minus I2. Okay, so what we can do? z1 plus z2 equal to 4 minus 2 plus I3 minus 2. So it will be 2 plus I. This we can do like this. In the same way, we can do subtraction also. Subtraction of complex numbers we can do in the same way. z1 minus z2 will be same, x1 minus x2 plus I y1 minus y2. We are going to treat as a real number with real number and imaginary number with imaginary numbers. Now we will come to the multiplication part. Multiplication. Z1 into Z2. So how it will be? X plus x1 plus Iy1 into x2 plus Iy2. So it will be like we will solving the equations. So x1 x2 plus Iy2 plus Iy1 x2 plus Iy2. So it will be x1 x2 plus I x1 y2 plus I y1 x2 plus I square y1 y2. I square equal to what? Before that we have understood I square equal to minus 1. So we can write it as x1 plus x2. Since I square is minus 1, so it will come minus y1 y2. Here we will take I outside of the bracket, so it will x1 y2 plus y1 x2. So this is the way we should do the multiplication in this case. Now come to the division part. For the division, parts, so for the division parts, z1 by z2, it will be x1 plus Iy1 x2 plus Iy2. To make it simpler, what we are going to do, we will multiply by this. Why we are going to do this, I will tell you in later section, but presently just and we will resolve the same as we have done in multiplication section for the multiplication. So it will become x1 x2 plus y2 plus I x2 y1 minus x1 y2 divided by x2 square plus y2 square. So this will be like this. So we have seen that the algebra of complex number does exist, and how we are going to do the addition, subtraction, multiplication and division. Addition and subtraction is the we have to add real part with real part, imaginary part with imaginary part. Same as we are doing equality, we are doing we make equal real part with real parts and imaginary part with imaginary part. Now come to the properties of additions of complex number. Means complex number follows what are the laws during the addition. Okay, during the addition means when we are going to add, which laws, which properties do they follow? Properties of addition of complex number. First one is closure law. Closure law. What does it say? It say if we are adding two or more complex number, then the result will be a complex number. Means if Z1 is a complex number, Z2 is a complex number, then Z1 plus Z2 will be a complex number. Okay. For example, we can check also anything. Means 3 plus I4, or we can say Z1 and 2 Z2. Then Z1 plus Z2 will be 5 plus I4. This is also a complex number. Now come to the second property. Second property they follow commutative law. Commutative law. So commutative law, what it says, it says Z1 plus Z2 will be equal to Z2 plus Z1. Means, what does it means? If we add Z2 in Z1, or Z1 in Z2, result will be same. There is nothing that we take which one we take first. There is no sense with the addition. Either we take Z1 or we take Z2, result will be same. Result will be equal. There will be no change. We can take here, suppose Z1 equal to x1 plus iy1 and Z2 equal to x2 plus iy2. We will consider these two example, these two for the rest of the property, and we will try to understand. Then Z1 plus Z2 will equal to x1 plus iy1 plus x2 plus iy2. We can say x1 plus x2 plus I y1 plus y2. Now we check Z2 plus Z1. So x2 plus iy2, x1 plus iy1. So again it will be same, x1 plus x2 plus I y1 plus y2. So we see it follow commutative law. Now we come to the associative law. Associative law. What is the meaning of associative law? Associative law says if more than two complex number is there, Z1 plus Z2 plus Z3 shall be equal to Z1 plus Z2 plus. Means if we do the application with first two and then we add it, the result will be added to the third one, should be equal to any two addition and result will be added to balance one. Means we are considering first two, Z1 plus Z2, first we will add it, then the result will be added with the third one, should be equal to whatever we consider plus this. So this is the associative law. Now we come to the additive identity. Additive identity. What is the meaning of additive identity? additive identity means for every complex number, if we add this complex number, the result should be the original complex number. Means if the original complex number is z equal to x plus iy, so the additive identity should be, suppose that is called a complex number a, it should be z plus a should equal to z. Always the additive identity is 0 plus I0, because if we add this to this, the result will be same. Next is additive inverse. Additive inverse says the complex number which after adding to the complex number z plus xy, additive inverse is the complex number which after adding to the complex number result to the additive identity. Means if z equal to x plus iy, there should be a complex number b which after adding with this should come to a, means x plus iy plus b should equal to 0 plus I0. From here we can see b equal to minus x equal to minus iy. Means additive inverse is always negative of complex number. Additive identity is always a 0 complex number. So we have seen the property during the divisions. Now we come to the multiplication, not division, sorry, addition. So the property which we had used for the addition will be the same for the subtraction also. Now the property which we are going to see for the multiplication should be used in the division also. So the properties for multiplication. Multiplication. First is the closure law, closure property. Same, if z1 z2 a complex number, then z1 into z2 will be a complex number. Okay. Second, they follow cumulative. So now also means z1 multiplication by z2 should be equal to z2 multiplication by z1. There is no preference which one we should choose. Either we choose first z1 or z2. Third, associative law. Means z1 z2 z3 is equal to z1 z2 and z3. Same, since there is no preference, so this we can use. Now we come to the sorry, today not feeling well, but it's a different. Okay. So next we go to the identity, multiplicative identity. We call it multiplicative identity. What is the meaning of this? It says the complex number for any complex number z equal to x plus iy, there should be a complex number which after multiplication with this result will be the same. Means z into a should be z. So we can see here a should be 1 plus I 0. This complex number, if we multiply with any complex number, result will be the same. Fifth, inverse, multiplicative inverse. You can say multiplicative inverse. So multiplicative inverse is for each complex number z equal to x plus iy, there is a complex number which after multiplying with z should give result as a 1. Means z should equal to I. If I is a multiplicative inverse, then result should be 1. For example, here x plus iy into I equal to 1. If we say I 1 by x plus iy, to solve, as we have seen, we will multiply with minus quantity, minus of x minus iy, so it will become x minus iy divided by x square plus y square. So if we multiply by this to x plus iy, the result will be 1. So till now we have seen the complex number, algebra of complex number, properties of addition and multiplication. Now we will come to the modulus of a complex number. Modulus of a complex number. Z equal to x plus iy. So modulus of z is denoted as mod of z. The mod of x plus iy will be equal to under root of x square plus y square, and it should be non-negative. Means we should not consider negative value. We should not consider negative value. We should consider only positive. This, okay. Now next comes to the conjugate of complex number. Conjugate of a complex number. Z equal to x plus iy. So conjugate will be denoted as z bar. It is called bar. Z bar equal to x minus of iy. Be careful. Whenever we require to make a conjugate, we change the sign of imaginary parts. We don't touch real parts. We change the sign of imaginary parts. Example, conjugate of 4 plus i3 will be 4 minus i3. Minus 2 minus i3 will be minus 2 plus i3. Okay, not plus 2 plus i3. Okay, This is not. This is the right. Okay. Okay. So in the next presentation, the next video, I will tell what are the properties of modulus and conjugate, some examples, argument or amplitude of a complex number, how to find out, then principal value of argument, how to find out. Okay. Till then, it's Madhav Kishore signing out. Take care. Bye bye.